Let us see how you can solve this problem. It is required that we found the area. And the area here we have two parts of the area. One is the polygon, which is A, B, K, C, and you go all the way. And then we have this sector, which is part of a circle. The sector is r equals to 50 meters. And the opposite angle, delta, and delta is 104.5900. Here is very important note that the radius here is vertical, which means it has a, depending on how you look at it, so alpha b k, because it is vertical, so it is 180 degrees, or alpha kb equals to 0 degrees. So this is very important because we will need it later. It is required that we calculate the area of the parcel 1, which is the polygon, using the coordinates method. Using the coordinate method, that means we need the coordinates. We do not have coordinates, and we do not have a data like one starting point. So we make, or we suggest, a starting point. And here in the question, it is suggesting that we use the point C with coordinates. There was a hint in the question. The coordinates of point C, assume it to be 100 and 100. So we start with point C as 100 and 100. And then we'll go counterclockwise with the points, and then we'll take C, D. We will calculate the departure and the latitude. This is the latitude and this is the departure. Of course, we need the azimuth. So what is azimuth? Alpha C, D. This one, we want to see the geometry here. What are we given? Alpha, we are given phi, which is the bearing. DC in this direction is given as north 1546 to the west. So the other, we need the other side, which is the opposite one, which is the back bearing. So we need to find the back bearing. The bearing is north and the angle and then to the west, while the back bearing, it is south, same angle but to the east. Once we have it here, so we need to calculate the azimuth from that. So the azimuth is C alpha CD will be equal to, look at this, this is in the second quadrant. In the second quadrant, the azimuth is 180 minus the angle. So here it's 180 minus the angle of the bearing, which is 15 degrees, 46 minutes, and 32 seconds. Fine, this is the azimuth of the line alpha CD. So what do we have here? What is the length of that? So we have the length 305. So we start here. So point C, the table, it has, first we start with a point, then with the course connecting this point with the next one. So we have C is 100 and 100. CD is a line from C to D. We have its length at this 305. This is given. And the bearing, it was south 15. It is not north. Phi DC is north, but phi of CD equals, which is the back bearing, it is south and going to the east. Then this one is what we convert into an azimuth. So this is the bearing and this is the azimuth. As we said, it is 180 minus 15, 46, 32, and this will give us 164. Now, what is this? This is the azimuth. What is this? This is the length. So we have the length and the azimuth. Multiply the length by the cosine, the azimuth, it will give you the northing here, the departure, which is minus 293, and multiply it by the sine, give you the departure. Now we will take 100 and we add to it the 82, and this will give you the coordinates of point D. And then you add this minus 293, which is the latitude, you add it to the northing, and this will give you the northing of point D. So now we know point D. So we're going to continue to point E. And we do the same thing. We have the length. So the line DE, this is the line DE. The length is 372. What is the bearing? The bearing is from, it's phi ED. Phi ED. So it's from this direction to this direction. So first we want to find phi DE, which is, instead of south, it will be north. And the angle is still the same. And here it is E. So we will have north and east with the same angle. This is in the first quadrant. Northeast is the first quadrant. So the azimuth is the angle itself. Now we will calculate the departures and the latitudes for the line DE, and which is the length multiplied by cosine the azimuth and sine the azimuth. The departure is the sine of the azimuth. So it's 372.38 sine 84. It will give you this, and cosine, it will give you that. Now we take this one the coordinate, we add it to the departure, and we take the latitude, we add it to the northing, and we get these two, and we continue. We continue until we go to point A, and then we find coordinates point A, and then coordinates of point B, and then to find K we need the length and the azimuth. The length, it's a radius, so it is 50. Can you see here? It's a 50, and we are it is vertical from B to K. Vertical from B to K, that means it has an azimuth, or let's say, let's start with the bearing. The phi of that BK, it's going downwards, so it is from the south, so it is equal to south, and it is 0 from the south, 0 degrees, 0 minutes, and 0 seconds, and going to the east or to the west, it doesn't matter. So it is a 0 southeast, and then, as we can see here, so how do we, this is in the second quadrant, second or third, so we add to it 180, and this is the azimuth of the line BK. Now we will calculate the same thing, the 50 multiplied by cosine and the sine, and these are the values. Minus 15, this is like a 0, but because of the Excel it gave some accuracy, or numerical accuracy, so it doesn't matter. 10 to the minus 15, it is a 0, and here it is minus 50, and we add this to this, and we add this to that, and finally, what do we have now? We have all the coordinates of the polygon. So we will use the coordinates method to find the polygon's area, and then we will add to it the area of this sector. The area of the sector, it can be calculated by the whole circle. It is pi r square, which r is 50, and here we have to multiply it by the ratio of the angle delta to the full angle, 360 degrees, and this one is 104 degrees, 104.5900. We are done. We calculated the area of the sector. We calculated, how do we calculate? Yeah, we're using the coordinates method. It is simple, using this one. Here we will have C. We will go from C to B, and we go counterclockwise from C. So we start with the C, and then we list the coordinates C, D, E, A, and B, and K, and we return again to point C. Look at the order of the points. So here it is C, D, E, A, B, K, and then we return again to point C. Put the coordinates here, just the coordinates, then calculate K1 from these. Multiply, plus, multiply, plus, multiply, add, multiply, plus, multiply, plus. Then you want to calculate K2. K2 is the other side, from here to here. Multiply and add, multiply and add, multiply and add. Then the summation of K1 is this one, summation of the K2, and then K2 minus K1 divided by 2. This is the result. The total is here. I'm not able to, because I'm doing the number minus K2 minus K1, and the result you will divide it by 2, and this is the polygon area. The sector size, as we saw it here, this is the sector. We add them together, and this is the total area, and that's it.